In the realm of industrial production, sprawling supply chain networks involving raw material suppliers, component manufacturers, and more are commonplace. In traditional models, without coordinated cooperation, parties may redundantly invest resources, leading to wastage. Hence, there is a need to establish a decentralized enterprise collaboration platform to facilitate cooperation among parties. We applied blockchain technology to establish a decentralized trust mechanism through decentralized distributed ledgers and consensus algorithms, thus eliminating the reliance on centralized authoritative bodies. At the same time, we have innovatively integrated BPMN choreography diagrams with blockchain technology to support the modeling and execution of multi-party collaborative processes. We have designed an integrated framework, IBC, which maintains excellent scalability and supports the replacement of the physical layer. Based on this framework, collaborating parties only need to focus on the business-related aspects above the physical layer. Firstly, we demonstrate the functionality of the multi-party collaborative model management section. Firstly, register two users to represent org1 and org2 respectively. Enter their usernames, emails, and passwords separately. Afterwards, they will log in. After logging in, they need to create their organizations, org1 and org2 respectively. After organizations are created, the dashboard displays organization information. Next, we need to create a consortium named Consortium 1, consisting of org1 and org2 organizations. After creating the consortium, the system will generate a default membership for the current organization. org1, as the founder of the consortium, invites org2 to join this consortium. After accepting the invitation, org2 will join the consortium using its default membership. It's worth noting that an organization can create multiple memberships within a consortium. org1 will additionally create a membership too. The next step is to create a fabric environment for this consortium, named env1. The second part of our demonstration involves physical resource construction, primarily focusing on the construction of Fabric and Firefly. The environment construction comprises 5 stages. The init stage creates a system membership and establishes a default orderer node. In the join stage, each membership joins the environment, creating its own CA and peer nodes. Once all memberships have joined the environment, we proceed to the start stage. The start stage establishes the network and starts all peer and orderer nodes. All peers and orderer nodes can be observed as started in Docker Desktop. Next, the activate stage creates a default application channel, and all peers join this channel. During the Firefly stage, it's necessary to start Firefly-related nodes, which depend on Firefly chain code. Therefore, we utilize the platform's chain code management functionality to install the Firefly chain code. Each user can only perform relevant operations on the peer nodes under their own organization. After each organization executes the install and approve operations separately, once any organization executes the commit operation, the chain code will be successfully installed. After successfully installing the Firefly chain code, we proceed by clicking Start Firefly to initialize and start the Firefly nodes. Each membership corresponds to a Firefly supernode. You can click View Details to access the Firefly Sandbox, Swagger API, and Explorer pages. In the third part, we will demonstrate the functionality of BPMN choreography modeling and execution. First, let's take a look at the BPMN choreography modeling functionality. We have integrated the Chore.js framework, which supports BPMN choreography drawing, downloading, importing, and other features. Additionally, we have extended some functionalities. Double-clicking on a message allows you to define its format, supporting types such as string, number, boolean, and even file. After clicking OK, the corresponding message format definition will be stored in the BPMN documentation field, supporting subsequent code generation and other functionalities. Furthermore, we support importing a pre-drawn BPMN diagram. After clicking Upload, you can navigate to the Deploy page to view all uploaded BPMN diagrams under this consortium. A single BPMN can create multiple instances. Let's create an instance named Name Test. Firstly, we need to bind the participants modeled in BPMN with the memberships in the consortium. Once all participants are bound, we proceed to the chain code generation stage. Clicking the Generate button will generate the chain code and Firefly interface corresponding to this BPMN instance. Afterwards, it's necessary to install this chain code on the peers of the respective organizations. This operation is similar to the installation of Firefly smart contracts as described earlier. Once installed, clicking Register will register the chain code as an HTTP API and invoke the init ledger method of the chain code. Afterwards, it will transition to the execution state. You'll need to select the corresponding membership to enter the execution page. White indicates a disabled state, green indicates an enabled state, red indicates a wait for confirm state, and blue indicates a done state. Clicking Next will trigger the execution of Start Event and Gateway until the choreography task. One participant will send a message, and the other participant needs to determine its validity based on the message content. If valid, click Confirm. When the gateway is enabled, clicking Next will automatically determine the execution path based on the conditions specified on the sequence flows. If the message contains a file type, you can click Upload to upload the file to be sent. We can view all sent message content and invoked chain code methods in the Firefly Explorer interface. Only the sender and receiver of a message can view its content. Others can only see the transaction ID pinned in the blockchain.